called. Okay, so I guess Python's class is a whole new set of topics. It's a huge topic, and our class just start to scratch the surface of it. However, I'm going to cover some, important thing about object-oriented programming. It's not just for Python, but any other, I guess, modern computer language has this feature in it. So we actually have objects all along during this course. You may not notice that Python can treat everything as an object, right? And the object has a type. So for example, integer is the object, float, and you can recognize this as a string. String is object. List is object. It's a compound object, okay? And then dictionary. So these are objects, okay? Objects with a collection, you can think about object as a collection of data representing the object, or and a procedures or interaction with the object. So basically, for example, in Python's list, right? So list one, you have a list 1, 2, 3, 4. It's object. You already started creating an object. Now, there's another way to create a list is call the class name. We call it class name, and then we can do some operations on it, like append. Right? Append is a function that's it's a built-in method, and you can append number to it. Okay, and then you can append again, append more to it. Right? You can even pop. So you can pop the data, okay, or pop 0, or pop the data, right? So these are the internal methods of objects. So you already know those basic classes as built-in. We call the built-in objects or classes. All right. So and as you know, object has type. Today, we're going to talk about the custom type. So we can create your own object or classes that way, right? So yeah, list tuple and strings are objects. Okay. So in terms of the internal representation of a list, right? So basically, this class or object have some kind of like encapsulation. Basically means you don't really so. To the user, you just need to know how to use it, okay? Initialize it. You don't necessarily care internal representation of how data is represented. That's a private thing, right? So for example, a list may implement the actual data structure using a linked list. A linked list is basically just a bunch of nodes with the pointers to the next address of the same type storage. And they're not necessarily continuous, right? Continuous from one to another. Okay, like a array in common sense. How to, and then you can you only care about how to access data. In the list splicing and get some. You have a function to get the maximum and minimum of the data, and you have append, extend, count. All these wonderful methods, right? So all in all, this is one of the concept object-oriented is basically implement the class. You want the internal data somehow shielded from the user. So in the future, if you have a better representation of the list, you can change it without changing the interface. So it's compatible to the old interface. Okay. So this concept of a class and the instance of a class is kind of important. So when you create, when we create those lists, right? These are individual instance of the class called list. And when you implement that class, we call it a class. So a class is just like building a house. You have a blueprint, and using the blueprint, you can build houses. These houses are individual objects. A class is a blueprint of the house. Okay. So how to create a class? Well, you have to, just like define a function, you want to define the name of the class. You define some attributes, and then from there you can expand on it. Okay. Let's just go into the details of creating a class. This is a simple class called coordinate. So let's just try it, right? First of all, it's like a define a function. You use a keyword class, okay? And you can call it coordinates. And then
Hi.
Mhm.
Quick question. In Java or like some other programming language, when you define a class, it actually has to be a capital.
Yeah, that's right. In Python, it's lowercase.
Is lowercase? Oh, wow. All right.
But the class name, by convention, make it uppercase, right? And then this, you may have experienced other languages, and you have a concept of inheritance. So the class have a hierarchy of inheritance, and the all grand parent of everything is object. So naturally, you can omit this. Just simply just do this, right? That's the simple class, and it's like a base class. You don't need any parent to really define the class. This is just a parent of object. Well, in this case, it's just yeah, you don't need to care for now, right? Simply you want to just like a define a function, you want a colon, that's important, and indentation, right?
All right.
Then within the class, you can define a bunch of functions. The mostly common function is a self function, which is like constructor in other languages. If you are familiar with that, basically, whenever you call and instantiate a class or object from the class, and this function is called first. Okay. Typically, you want to maybe add some initialization of the data in the class. But in this case, I'm going to just invoke X and Y, which is a coordinate, right? And self.x, self.y equals to y. Now, this self, okay, we can talk about more later, but this is a indication of like a pointer to the instance of the class. So when you initialize a class, how to differentiate one house to another, each one has a unique identifier. So self basically kind of like refer to, hey, this is the instance the self. So every instance will have a different coordinate. So this self is important. And then I think that's a basic class, right? Now you may want to okay, so let's see. We define the class. This is the simplest class ever. Let's see. You may want to let's see. Okay, so these are the anatomy of a class, right? Init function, which is called constructor. The self is a parameter referred to an instance of a class. X, Y is whatever actual parameter you want to pass in to the internal data. So self.x, Y is once you assign there, it is available for all the functions within the class. So they are shared. Okay, so that's the idea. You don't need to pass parameter to internal function. And we can once you have that, you can just say initialize it. So we are building a house now, right? This is a blueprint, right? You define a function, you call the function, you define a class, you initialize from the class. Now, because you have this extra parameters in the function, so you can actually pass in like 3, 4. That's one instance of point. Maybe C2 is coordinate 0, 0. So it's at origin, right? Okay, so you have two points. Now you can print them, C1, C2. Let's see what's going on. Right, so is it Why this is not printing? Hmm.
Do you have to do something with the
I have this C1, C2. Let's see if I can run. Something wrong with my online IDE. What else? Shell. Give me a shell, please. Let me refresh it. Hold on a second. I don't want to lose this. Refresh it. Reload. All right. Okay, run. Okay, so now you have something here. Just a online error. Okay, let's run again. You can see it prints out 2 objects, but it's very cryptical, right? You cannot this main dot coordinate object at this address. So these are 2 objects. So how to make this print more, human readable? Well, you can actually, turns out every class you can define this special function, double underscore, string, double underscore, and this function will dictate. You can override this function to tell the user that this is how I want to print out myself, right? So you can print out, you can return a string. Let's return an f string, which is self.x, right? Comma. Okay. Self.x plus comma, and then self.y. So in this case, I'm gonna print out this maybe in a brackets, right? All right, so here you go. Yeah, self.x, self.y. Let's see, did I miss anything? Okay, let's run it. Okay, you can see now it's printed out like 3400, just like a normal coordinate. So this string function is really important. I mean, like useful, right? So you can change this to any other form you like. Okay, so that's the internal method. Now, every internal method of the class, you need to start with self, because then you can refer to itself, because the self points to the instance, right? So this is the 2 differences. We can add some more function, like how to calculate distance from self to another point. Okay, so define the function inside the class is just like define a normal function, except you need to add the self. So how to calculate the distance between the 2 points? Well, there's multiple ways to find the distance. Let's see. There is a formula, right?
y1 plus
yeah,
x.
so it's like self.x squared. I can use this as a squared, right? Plus, well, self.x minus other.x, right? Other is the other point. And then, and the whole thing, I get squared. I can use this as a squared, right? Comes as 2 plus self.y minus other.y. This dot notation basically says this is attribute, right? Which we define here. Understand? And then 2, and that you add them and you do a mass.sq. Hold on, is that mass function? Let's see. Does it have a distance? Yeah. Okay, so this is actually another way of doing that. It's just the power of, yeah, instead of the sqrt function, we can do this, the whole thing, right? And we can do times 0.5, which is power of half. So this is the distance. We can return it. Okay, now how to use it? I can print out C1 dot distance to C2, right? Okay, that's 5. So it's a Pythagorean theorem 3, 4, and 5. So that, or I can print a C2 distance to C1, same thing, right? So if I do C2 distance to C1, which one is self? Which one is the other?
The
There are 2
distance.
parameters here, yeah. Again, like I said, the self refers to whoever calls this.
Oh, C2 will be.
No, C2, yeah, C2 is the self and C1 will be the other. Okay, so the distance will be the same. Now you can also do this. So you can also call this class function like coordinate. If you do coordinate dot distance, now you have to pass 2 parameters, C1 and C2, right? So it takes 2 parameters. And then that will give you the same answer. Okay, so you can either use the class name dot distance. The class don't know which point, so you give them 2 points, right? If you do C1, it's already inferred from this guy. Oh, I'm calling the C1's method. So this self refers to the C1 and you passing another C2. Okay, so that's basically the gist of defining a class and using class. And just you might make sure that you understand this internal attributes are shared among all the functions inside the class. Okay, so it's like a global variable, but it's better, right? So it can be accessed from other. On the other hand, if you want to call the function that you defined within other method, you have to refer to as self. Like if I want to define, I don't know, define distance 2, right? And I'm going to reuse the distance. I'm just return distance and passing the other, but I have to use self.distance, so it will also recognize as a internal function. So this self is necessary if you call, even if you call the internal function. And then I'm gonna take that and square it. Okay, so if I do distance 2 and then run it, it's gonna be a squared version of that, right? There's some errors. No, it's 5. What?
I think you have to after the 0.5, you have to press enter. It's probably something like that. So another line.
Should be fine, because if this is the line, not this 2. What's wrong with, is that the indentation, or sometimes it's indentation, right? This 2. Yeah, I don't know why there is. I'm gonna put a this. Is that aligned?
Yeah, it looks aligned. Everything looks.
So why there is the line here? I'm gonna just print. I'm gonna print. Yeah, I'm gonna print. Oops. Print self.x. Interesting. This time it oh. Okay. Let me just try it. Did I save it? I think I saved it. Run it. Come on. Something wrong with this online version. Let me just refresh this. Okay. This is real. Let me refresh it.
Which I guess I was gonna ask you too. How come you don't use the IDE?
Yeah, why? Because this is easily shared by you guys. So you can actually get the URL and take a look after class. Okay, if I use IDE, you can see it after class. I can use IDE as well. If the online version don't work, then I'm gonna use IDE. And I'm gonna do dist. Okay. Yeah, run it. I may have to use today because this is really slow. Still 5.0. Is I ignored my, anyway, there's another website called Python Tutor. Let's do it here. Visualize it. Sometimes it's good to visualize it, right? All right,
Yeah.
so visualize. Yeah. Okay, so I like that. It's actually give you some memory map, like visualize what's going on. See, self is pointing to this X and Y, and it creates C1, C2, distance, self other, return, self distance other. It calls the distance and return this, right? Which is 5.0, which is 5.0. So that's good. Now, if I want to modify this to 0.2, so squared again, it should give me 25, right? Yeah, 25. So this works. It's just the IDE. Okay, I don't know. Today is not a good day for this IDE. 25. It works now. I don't know why this one has a lot, but anyway. So that's a basic thing. I also talk about these two method way to use this method. Okay,
Yeah.
and this print function. There's a lot more special naming convention for the internal function. We can talk about this quite soon. Oh, which is here.
Oh.
So, yeah.
Oh no, I'm just looking at it. I'm reading out loud. Sorry.
Okay. If you want to compare to object, or remember, you can compare string, like string 1 equals to string 2. You can call length of the string. You can call if string 1 is greater than string 2. It can even concatenate by add a plus. So when you are doing this thing, what's behind the thing is actually you have to define the corresponding function or method in the class to let the computer know how to do it whenever you have this user have invoked one of the signs. Say if you want to say C1 plus C2, you have to define the add function. Let's try it. So let's just try the add function, right? Remember double underscore. So you want to add 2 points. What does that mean? You have to define it. You can return self.x plus other.x, comma self.y plus other.y. That makes sense, right? You add them together and return this tuple. So if I do C1 add C2, okay, C1 add C2, what do I got? I got 3 and 4 because now let me make it a C3, right? C3 is like 12, 41, 42, okay? And C1 plus C3. So what we got? There's some attribute tuple object has no attribute X.
You have to put a coordinate for C3.
Yes, we want to put the coordinate here. right? So we can do, yes, we can do coordinate this and that. So I'm gonna return a coordinate as well, and I'm gonna print it out. And there's still something wrong. Tuple object has no attribute x. Okay, what does that? Oh, you know what? This is my fault. This is the tuple, not coordinate. So C3 is a coordinate.
Yeah. I was trying to say.
You mean that? Yes. Okay.
Yeah.
Now I got it. But this one also works, right? 1546. I can even get rid of that. It will give me a tuple and not coordinate, but that give you the visual way is the same, right? 1546. Okay, so yeah, that's how you define a class. Now we can define all kinds of other things. I'll leave it for your exercise, like multiplication, subtraction, equalize, how to define equal, right? Equal. Let's say define equal. So why we want to define equal? So how to define if these 2 points are equal? Well, it's simple, right? Return self.x is equal other.x and self.y is equal other.y, right? And I'm gonna print if C1 is equal to 3, it will be false, right? If I want to say if C1 is equal to coordinate of 3 and 4 again, so this is 2 different points, but it will say true, right? Now, if I want to say if C1 is this guy, what I got false. So you see the difference is means these two are the only object in the memory. So if I give you a visualization of it, I guess this will help you understand this. What's the difference between is and equal? We know equal just call my function and compare if x and y are equal. Okay, let's see. Is there a actually, let me do C4. C4 is coordinate 3 and 4 again. Let's see if C1 and C4 are the same. It's not, right? Why? Although the coordinate are the same, but right, you can see C1 and C4 are pointing to a different location. So there's two memory location that host the x and y, but they are 2 different points. Okay, if they're pointing to the same one, say if I do this, right? If instead of doing this, I'm gonna say, okay, C4 is equal to C1. Okay, let me run again. Okay, you can see this C4 and C1 points to the same location, right? So they are indeed the same objects. It's when I say C4 equal to C1, it's just the aliasing now. So C4 and C1 did not, the computer won't create a new copy of memory into the space. It's just going to point the pointer to the same coordinates. Okay, so there's only 3 coordinates created in the space. The C4 is just aliasing. That's why C4 is C1, and of course C1 equal to C4. So is a more strict condition than equal. All right, so now you can implement all these other functions yourself. So that's pretty much the example for the class. And there's another example of fractions. It's just another way. It's a similar concept. Okay, I'm going to give you the PowerPoint slides so you can take a look yourself. There's more information on that slides than I can talk about today. So Let me put it into the chat, and you can take a look.
I feel like
All right.
Java. Okay,
It's like Java, Java, yeah.
Yeah,
so,
Java is for Java's object. To me, I feel like Java's object, OBJ or OOB.
Oriented, yeah.
I feel like it's way better than Python's. I don't know. I've done a lot of Java object oriented, but
yeah, Java is a classical pure object-oriented languages. Python has some limitations, like for example, it does not have a concept private protected those scoping. So everything is public. For better or worse, you don't want to use this parameters or attributes directly. You need to have a getter and setter function. So you only program to the interface. So you only expose the functions, public functions, to the user. So okay, so this is another example. You have a fractions, and you can initialize with the numerator, denominator, and you can define how you want to print this out. And then function can be initialized like that, fractions. Now you can define how to add and subtract. You have a to get a function, right? Get numerator, get denominator. So use the getter function, you can get this internal attributes. Although user, once you cannot prevent user from just directly referring to your internal data, but don't do that, right? So you can get numerator. That's a better method, better way to handle this.
All right.
Okay, so yeah, just like Java, you have getter and setters, and these are the two implementation of how to add and subtract stuff. These are the special name that you have to follow, and then of course you can define it. And you can also define a convert function to convert that into a decimal point, which is simply just using the Python's division. And the third example is like define a data structure, right? A set of integers. So here you go, integer set. It uses the internal list as internal data structure, and you want to let the user insert. Well, you can just append to the list. You can get the member functions. So member means if the element is in that data structure, you can remove it. You can just call the remove function for the list. You can call the string function. We're gonna sort it and print it in order. So that's the integer sets class, and you can use this freely. Once you know the class, there is a ton of opportunity for you to write the code in an object-oriented way. I think it's a very, very good paradigm in some areas, right? The power of OOP lies on they not only bundle the data, but also the methods. So naturally, say, for example, a text-based game that we just did the first semester. Think about how you can, using object-oriented function perspective, to re-implement this. So as you recall, right, in a text-based game, the major map is basically a dictionary, right? So you can navigate to a different room by referring to a different key in the dictionary, right? And also inside the dictionary, you have items that you can retrieve. Well, if you were implemented in an object-oriented way, right? Say if we want to define a class called room, right? Maybe, I don't know, you can even make each room a base class. Okay, let me talk about the room. Like, I don't know. So in the room, you can think about, I don't know. I think it's a natural to design this game using object-oriented like init function. Don't forget the self. I don't know, in the room, what do you have? Object, right? Item. And then you have direction, right?
Yeah.
And a bunch of others. So self of item, equal to item. You can assign them item self.direction equal to direction. Direction is in Python 3.x, you can give them it's not required, but I would recommend to give them a type, right? Direction is a dictionary. Item, you can do this simple. Item is a string. Okay,
Yeah.
you can do that. So basically, you can say, I have a string. Like it's Python. Some of the tools can help you to double check if you're using it in a different type. It'll give you warnings, right? So this is a good habit. You can say item is a string, direction is a dictionary. So direction can be the normal dictionary, and you can define next room, right? Next room function, and give a direction. Okay, so you can say if dir in self dot directions. Right? Let me just give it directions. Right, so pro form, just multiple directions. So then and you can do something here, right? I'm not good. So you can implement that. Else you can say print. You can go that way, something like that, right? So you can see you can implement in an object-oriented function. You don't necessarily use a dictionary. It's just we haven't talked about this when you are implementing this project, but now you have this concept of object-oriented. Now you can also define either get item, right? I cannot spell get item, and don't forget self. You can actually, I don't know. Maybe you can even have self.items is equal to a list, and then you can say, self.items append self.item, right? And then self.item is none. So you just say, I don't have any items. It's gone, right? So something like that, okay? Yeah, and then you can define other objects like big boss, right? So like self.health level equal to 100 to begin with, self dot like a medicine item initially is empty, and then like define a fight function. I'm just saying, right? See, this is very natural now. The boss can do fighting, and if something happens and and you can say self.health subtract 10, right? Every time you get hit, your health level goes down, and something like that. So these are very natural to define. Now, before you design the game, you can draw a diagram, like each box represents a class, and then you can say what's the relationship between these two. So this is a whole object-oriented design. Once you learn that, it's basically very powerful, right?
Yeah.
So you can implement this customized class. Just give you some ideas. And then there is a definition of class definition of object type and instance of a class. Okay, so I think just to scratch the surface, you can look at the notes more. You have any questions on this week's project, or not project, but labs on stuff?
No, not really, not yet.
Yeah, it's really simple, right? And once you understand how the class works, it just asks you to add some function into the class or method. Can define a print info and declare a attribute, right? So this is super simple, and you input information, year, model, value, and you can just, print them out. And that's the car value. And for the 8.10, it's winning team. Basically, you just write some, finish the to-do, right? Define the get winning percentage function, right? So you can just define get win percentage. And then don't forget you need a self, right?
Yeah.
Everything else, it's already in the attribute, so you don't need to pass into your function per se. You can actually access to them in your function, right? That's the key concept. So you can use that to formulate your winning percentage formula, right? I think it's something like team wins divided by the total, right? Total is team wins plus the team losses, right? Of course, you need the self here, right?
Yeah. Oh, spelled that wrong.
I know. I don't want to make it right. So it's like so now you can just define like self. You can even define self here, new self like average equal to that, and then once you get that, you can return, right? Return average. Now you don't need, if you return, you don't need the self, because you don't want it can be local. You can just return the winning average, and they can using that to calculate the winning percentage. So yeah, it's pretty simple. I think this week is simple because you just spend a lot of time on the big project, so it's time to relax. All right.
Yeah.
Any questions? Yeah.
No, not for the classes. I think I
Okay.
get it. Just have to like work on it some more.
Let me first of all just stop the recording, stop sharing, and